All right, everybody doing good today? Good. We're a little past 8 o'clock. We were having some technical difficulties. Thank you, James, for helping us. But I'm going to go ahead and get started. We got a lot of good stuff to talk about today. And if you normally come to county meetings and hear me talk, I'm going to do something a little different today. I don't normally do that, but I decided we're going to have us a little fun. First thing I did want to point out was that we started a podcast this year. For those of you that are podcast listeners, okay, I know there's some people in here that do listen, and that's great. If you don't get enough of me talking this time of year, you can listen some more, all right? But at the end of the day, it's just to give more timely updates throughout the season. There were some things that came up this past year that, I would think are pretty serious and things that I would think would be helpful on your operation. But if you want to scan one of the QR codes, you can. It'll take you either to Apple Podcast or to Spotify in terms of whichever one you like to use. If you have an iPhone, you already have the podcast out from Apple, okay? You got it, Scott? You good? Yeah, you working on it? Hey, John, can you just send it to okay, thank you. All right, so the other thing that we do, a little more traditional, is the Cotton Team website. That code on the right is it'll take you straight to the website. But really the reason that I show this is because there's a box in the top right of the home page. And if you put your email address in there and click subscribe, you'll get an email every time I post something to the website, okay? Whether it's a new podcast episode, new edition of the newsletter, updates about meetings and stuff like that, okay? Now, if you've heard me talk this year, normally from this slide is where I go into the variety trial, but I'm not going to do that today, all right? I have copies of the variety trial results up front, okay? And if you want to study those a little bit closer, you can come get you a copy, all right? Trey worked real hard to get them ginned on time, so Trey, thank you very much. But all that data's up here, and two, if you come to your county meeting, I'll go a little more in depth on my thoughts with respect to variety selection. But there's really two things that I wanted to talk about today. One of which is something that isn't the most fun thing in the world, but I feel like we got to talk about it. Okay. Anybody see some stuff that look like this? Yep. Okay. Yep. A lot of people raising hands, nodding heads. Okay. Now, a little bit of history here. Okay. In 2017, our friends in Alabama discovered a virus in cotton. Okay, it's called cotton leaf roll dwarf virus. Okay, in the year 2018, we found it in Georgia. Okay, and our virologist, who is next door, Dr. Sudeep Bag, has worked extremely hard on cotton leaf roll dwarf virus over the last nearly 10 years, which is kind of hard to believe. Okay, now, one thing that is extremely consistent with this virus is that if you see plants with these type symptoms, okay, 9 times out of 10 it's going to test positive for that cotton leaf roll dwarf virus, okay? Now, that's not to say that plants that don't show that will not test positive, but 9 times out of 10, when you see that, you're probably going to test positive for cotton leaf roll dwarf virus, okay? Now, if you've been in the cotton business a long time, what's it look like to you? Thank you. Wilt. Okay. So, with that in mind, we decided this past year that what we were going to start calling this was virus-induced bronze wilt. Okay. Because it was being separated in some segments of the industry, and really I felt like they needed to be connected, okay? Because like I said, they're very closely associated. Now, right or wrong, whatever, right? Things change. It's science, okay? But at the end of the day, that's what we're calling it for now, all right? Now, the big question is, why did it happen? Why did it happen? And I really, really, really wish I could tell you why, okay? But I don't know, okay? And it's, I've looked at weather data. I've looked at maximum high temperatures, number of sunny days, rainfall patterns, low temperatures, relative humidity, all that fun stuff. And I cannot find really a difference between 2024 and 2022, okay? So I can't identify why it was so bad in 2024, but it was alarming, okay? And there's a couple reasons for that. Now, historically, some of the guys that raised your hands, you've probably planted some of the Dyna-Gro cotton in the last few years, okay? And if you have, I hope that you've not been sold a bill of goods that you weren't ready for. Most times, if we see these type symptoms, we're going to see them in one of those 3 varieties, okay? And really it's tied to, the Dyna-Gro 3615 and 3799 have been doing really good in the trials, okay? And so a lot of guys started planting them. We'd see it, maybe 1% of the plants, nothing crazy, but it's still making hell out of cotton, right? And so who cares, right? I mean, we're going to keep planting it. We don't see that much of it, and we're making really good cotton. Now, the reason that 2024 was alarming was because bronze wilt-like symptoms were observed at high levels in 2 new varieties in 2024, and in the spots where it was the worst, we saw 50% symptomatic plants and even then some, okay? Now, I've talked to my friends in the seed business a lot. I hope they're going to still be my friends after all this is said and done, but at the end of the day, I want you guys to know what you're getting into, okay, with these varieties. And so I've told them, said, hey, if your variety is one of the ones that we saw was showing it a little bit more, then we're going to talk about it, okay? And so this is a list of the varieties that are more likely to show those bronze wilt-like symptoms, okay? If you can take a picture of it, that's fine. This, of course, is being recorded. But also that list is in the production guide as well if you can't remember that list. But you see the 3 there that I talked about earlier, the Dyna-Gro varieties, but then there's 2 more with Next Gen 5430 and Phytogen 475. Okay? Now, the question is, what do we do about it? Okay? What do we do about it? And I really just got one question for you. Okay, what is your tolerance for seeing those type symptoms in your field? That's the only question there is, okay? If you answer you have 0 tolerance, that's an easy decision, right? If you have 0 tolerance, don't plant one of those 5 varieties, okay? But there's a lot of people in this room that are looking at that list of varieties, and they say, man, that's some of my best cotton, okay? Some of my best cotton come from one of those 5 varieties, all right? And that gets a little more complicated. If you answer that you can tolerate the symptoms, okay, then the only thing that I can tell you, and it's really more anecdotal than anything, is try not to plant it too late, okay? And if I had to put a date on it, I'd say May 15th to 20th, okay? If you're going after May 15th to 20th, let's try not to put those in the ground because you're putting them in a position to be vulnerable, okay? I'd try to get them in the ground before that, all right? Is that clear with everybody? Okay. Now, the big question was, I talked to a lot of people this summer with seed companies, and they said, well, Camp, we hadn't seen it reduce yield, so why does it matter? Okay, we're just going to wait, and we're going to see how this all shakes out, and we'll make a decision whenever we make a decision, okay? So the question is, what about yield? All right, we got a few county agents in here. They were extremely helpful with this, but what we did, we had 4 of those 5 varieties in our on-farm variety trial this year, and so our county agents went out and did counts, and we kind of separated it into 2 groups, where it was really bad and where it wasn't really bad, okay? And where it was really bad, okay, plain and simple, all right? 30 to 50% symptomatic plants, that includes sucked down, dead, dying, whatever, all right? And you can see it's kind of concentrated in the southwest part of the state, Brooks, Mitchell, and Colquitt County in our variety trials, right? But at the end of the day, whenever you look at 2038 compared to the 4 varieties that are a little more likely to show those bronze wilt-like symptoms, okay, you see 300 to 400 pounds of yield loss, okay? And in a year where cotton is selling for about 66 cents, that ain't going to work, okay? Now, the other thing, there's 2 sides to every story, right? The other thing is, whenever we saw less than 10% symptomatic plants, guess what? It didn't matter, okay? Same thing we've been seeing the last few years, right? If you don't have the symptoms, it doesn't matter, okay? Those 4 varieties are yielding up there with some of our race horses that are in the trial, okay? So, the take home on this is I'm not sure why in 2024. I'm confident that it will happen again, okay? I am. I mean, I don't know when. All right, I just know that it'll happen again, okay? 0 tolerance approach, don't plant one of the 5 varieties. You can reduce your risk by avoiding late plantings with one of those 5 varieties, and high levels of symptoms can reduce yield, but where there are no symptoms, it doesn't really matter. Okay? This is a pretty touchy subject, so are there any questions about this? I want to make sure it's all clear to everybody. Okay. Now, the thing that I'm changing up on this talk compared to my normal county meeting talk is we've been talking a lot about deer, right? There's people in this room that got a deer problem, right? Okay, there's a lot of people that walk a lot of cotton and see deer issues. And really, this started a year ago. We distributed a survey at county production meetings, and it really was amazing to see that growers and county agents and consultants all agree that white-tailed deer are the biggest pest of cotton. Okay, and that's expressed in millions of dollars here on the y-axis. Of course, the deer stuff is based on survey data. I got data on other problematic pests like pigweed, nematodes, and stink bugs from Culpepper, Kim Wright, and Dr. Roberts. And I mean, really, it's just far and away, right, one of our most problematic pests. Okay, now, the thing is that we started doing a lot of work this year. Okay, the first thing we did was we went out there and I told my crew, I said, all right, we're going to act like deer. Okay, let's pretend we're deer out here, and we just started cutting on plants. Okay, and so we did 2 different varieties, an early maturing and a full season variety in the same study. And really, if you've seen deer eat on cotton, right, a lot of the work that's been done like this is done with a single feeding. So how many times do you see a deer just eat it once if it's not below the cotyledons, right? People shake their head like this. They say no, okay? If you eat it if a deer eats it above the cotyledons, they're going to keep coming back, okay? So we decided to look at 4 different feedings. Of course, we started off with 1 and then added 1 every couple weeks for about 8 weeks, okay? And we snipped off every growing point, about 2 to 3 leaves, okay? Now, we did an early planting and a late planting, and in the early planted study, we saw what you expect to see, right? The more feedings you had, the more yield you lost, and really at 4 feedings, average across variety, you lose 50%, okay? But you've got the early planted stuff, right? It's a time thing, okay? But then the thing that was interesting was the late planted study, okay? And there was a variety effect in this particular location this past year. And you got your 2 highest yielding treatments in the non-treated, right, regardless of variety. But the interesting thing is that a single feeding in an early maturing variety did not statistically reduce yield. Yeah, you see a little reduction, right, 250 pounds, okay? But at the end of the day, that's still pretty good, 1278 with a single feeding. Now, in a full season variety, same single feeding, you see a yield reduction of 50%, okay? The other thing that was kind of neat was whenever you have an early maturing variety with 2 feedings, it's yielding similar to a full season variety with 1 feeding. Now, what's the whole point of all this, right? It's really cool, okay, in my mind. But what it tells me is that if we get our backs against the wall, like some people did in 2024 in terms of planting your cotton, okay, we can look at an earlier maturing variety to try to reduce risk of significant yield loss from deer, okay? It's an interesting thing, whether you get your back up against the wall on your planting date or if you're replanting after a deer issue or something else, whatever it is, right? We can look at an earlier maturing variety and see what's going on there. Delta Pine 2012 is not deer resistant, Jason, so we're not going to go there. So that's a great question. That's a great question. I drove the picker over this study, and it was really fascinating for me to sit in the picker seat and go from 3-bale cotton to absolutely nothing, okay? That treatment on the right averaged 34 pounds of lint to the acre, okay? So to go from 1,600 pounds down to that was just incredible for me to see. But the other thing that we've done this year, and a lot of y'all know about this, is do some of the on-farm work in terms of real yield losses to white-tailed deer, and you see the cages in the picture there. A lot of people have seen them. They say, man, there ain't no way the deer stay out of the cages, right? I mean, they're short, they're not that big, but we did do a lot of testing on that not far from here, and found out that they're not going to jump into that little old cage. I don't know what the deal is with it, but they just don't want to, all right? But you can see inside the cage you got totally normal cotton, and in between it you've got it's eaten to the ground, okay? We did 20 locations across the state, really just trying to capture what is going on with the deer situation, and we were able to separate it into a couple groups, and really kind of the cutoff was where we had 40% damaged plants at the end of the year, okay? And so that's kind of what it was based on. Really, most of the locations that were on the experiment station where I expected to have issues are in our less than 40% damaged plants at the end of the year, and most of our on-farm locations were included in the severe category. Okay, I'm going to show a little bit of data, but it's pretty neat. This is early season stand, and this is the percent of plants that were killed right out the gate, right? Bitten below the cotyledons, okay? 11% where we had high damage, and then 2% where we didn't. But then even the percentage of plants that were fed on above the cotyledons, right? Left alive, they had a chance to make something. You see 56% of the plants were fed on in our severe situation, and less than 10 in our less than severe situation, all right? And this is just a picture, and again, I mean, it's just fascinating for me to see even just the potential of some of these fields, right? What would happen if we put a high fence around some of them? That's what it would look like, okay? This is Square and Cotton in Coffee County, and then on the right, you got sticks, okay? It's regrowing a little bit in the picture, but you can barely tell. All right, it's fascinating to see the potential of these fields. Now, the thing is that at the end of the day, we're showing yield loss, right? I mean, no crap, okay? Deer are reducing yield on the farm, okay? In our severe situation, you see nearly 200-pound yield loss just from deer feeding, and then where it wasn't so bad, it didn't really matter, okay? We got the same yield inside the cage and outside the cage. So really, the take-home points to me are that the deer problem is real, right? That's the whole point of that study, okay, is to say, hey, this is not just something that we're belly aching about, okay? This is a legitimate issue, and we got to get some help, okay? It's reducing plant stands, plant heights, delaying maturity, which impacts our management decisions, and it's some really good data to illustrate that the problem is real, and that's kind of where we're going next, right? So, you know, we need to continue the work that we're doing. We're attempting repellent work. I'm going to talk about that pretty quickly here in a little bit. And then we're doing additional work on crop management strategies in response to deer pressure. But really, the main goal is to sit down with groups like Georgia Farm Bureau, leveraging our political capital with groups like the Georgia Cotton Commission and Cotton Incorporated to try and talk with DNR groups about real solutions, okay, to this issue. One thing, whether you think it's a success or not, okay, I think it's a huge success, is the increase in funding for the Georgia Hunters for the Hungry program. All right, this past year, Georgia Farm Bureau lobbied really hard to get $300,000 put into that program. And if you looked at the website a year ago, you would have seen 12 processors, and from where we're sitting, they were an hour and a half away. Okay, so I couldn't donate a deer if I wanted to a year ago. This year, there's 60-plus processors, I mean, within 30 minutes of here, okay? So that, I think it's a success story. But, of course, we're going to continue shedding light on the issue. I did do my part this time, okay? I even gave some away, Dr. Snyder, but I ended up with 12 this past year, all right? So the thing that is different with this talk, I've only given this one time, but really, you know, what people want to know is, what are we going to do about it? What are our options, okay? And really, they're pretty limited, okay? They're pretty limited. We got three things that we know can help, all right? The first one is depredation permits, all right? Red tape, a little bit surrounding that, okay? You've got the fact that you don't want to stay up all night shooting deer and farming all day, right? That's a big deal, okay? If you're farming rented land, you may not have the hunting rights, okay? That's a big deal, okay? The red tape associated with it, of course, it's kind of, I went through the process of getting one this summer. I didn't use it. The deer were eating my potatoes out of my garden. I just wanted to see how it works to get one. But, you know, more of what I'm learning the red tape is they give you an allowance, right? They say, hey, you kill 10, right, and then come back, okay? You shoot your 10, you go back the next day, and they say there's no way that you did that, okay? So that's some of the red tape I'm talking about. And really, you know, there's some folks that just don't want to shoot them, all right, for whatever reason, okay? I did have a conversation with a grower this year that told me that, all right? Now, the other option, another option is fences, okay? But again, this is really only an option on owned land, right? You don't want to invest the capital to put up a high fence on rented land and lose the lease, okay? And so, and I mean, too, it's expensive, right? $8 a foot was a number I heard thrown around about a year ago, okay? Intensive to maintain. One of your laborers on the farm, right? That's about going to be their job, is checking fence, all right? And if you don't have somebody doing that for cows, you're going to start paying somebody to do it. One of the big things that I think is a pro, if you got a hog problem in peanuts, then hey, that's a real option. Okay, if you got a hog problem in peanuts and a deer problem in cotton and peanuts, then that is a legitimate option, and it's viable for if you own the land. Again, but expensive, intense to maintain. But really, what people want to do is spray a repellent, right? It's easy, okay? You put it in the tank with everything else, you run out in the field and you spray it, and the deer just magically stop, okay? All right, inconsistent at best, based on the stuff that we've done, based on stuff that other people have done, and it's certainly ideal because of ease, right? This is a picture I took from a group out in Michigan, okay? They're doing some repellent stuff. Their cages look really similar to ours, which is funny, but of course they're spraying a repellent and chasing deer out while they do it, okay? So, I mean, come on, right? Now, Sarah Hobby's in the room, and she helped out with a lot of deer repellent work, attempted deer repellent work this past year, okay? We wanted to look at a bunch of products, application timings, rates, all that fun stuff, okay? I think it was 6 trials, 7 maybe, and it was in a 10-acre block of soybeans, okay? We set out to really try and get after it this year in terms of the repellent work. That's a list of the products we wanted to look at. Timings, weekly, every other week, finding the optimum time to start and stop spraying these products, and then trying to back rates off because these things ain't free, right? If we can reduce the rate, it might make it a little more feasible and get similar control, okay? We very quickly found out that this is very tough to do, okay? It is very complicated to do this kind of research. I'm gonna show you why, okay? In this bottom corner, if I start eating into your time, stop me, okay? Because I keep going. Okay, so as I mentioned, we had a lot of good intention, but it's very complicated. And this is a picture of the animal science farm. It's, maybe a mile from here, okay? Deer pressure in this spot is incredible. Really just where that red circle is, okay? We put out some repellent stuff a year ago in 2023, I guess that it was, and this is a video of that study. All right, this is Dr. Philip Roberts. He's walking through the non-treated portion of this study, okay, and then just all of a sudden you see something change, don't you? Whoa, yeah, all right. So, in that part of the field, we had incredible deer pressure, sprayed the repellent, right, and it was working, okay? Now, the thing about it was we said, well, if we've got the deer here, all right, surely, it's not 200 yards over here to where this 10-acre block was. And initiated all those repellent trials inside the big red circle, and I want to show you what happened, okay? So in this area, we had cotton planted in these 2 fields in this block over here. Dr. Mumford and Dr. Nino Brown planted peanuts up here, and then we filled in soybeans in that little section where the small red circle was. The soybeans on the right side of the screen and soybeans on the south end of this pivot right here. And you can kind of see how it gets complicated on you, okay? The peanuts in the top, the deer ate them, okay? Soybeans, where all the repellent trials were, didn't touch them, okay? I'm telling you, could not find a deer track in them, okay? Cotton, right next to those soybeans, they ate on that a little bit. Cotton down here, nothing. All right, these soybeans down here were eat to the ground, and these also here got munched on, all right? There's no rhyme or reason to what they're doing, okay? I think that some of them are coming from this wooded area here, eating those soybeans. These are coming from here. And then the peanuts, there's a pecan grove up north of there. They're probably coming south and eating on the peanuts. So they're coming from every direction except where we wanted them to come from, right? So it's extremely complicated to try and do this type of research. But at the end of the day, I did want to make a slide on viable options for deer repellents, okay? Obviously, I showed the video. We've seen them work, or else we wouldn't be investing all the time into looking at it, okay? Now, I don't have much hard data to share in terms of deer repellents, but, I have made a few observations, all right? 2 products that I've seen work, okay? Desex is an insecticidal soap, and Trico is a Helena product, okay? Sheep fat. A lot of guys know that one, okay? Trying to gather more observations on the other products, okay? I can't say they do or they don't or whatever, all right? But the take home for me is that they work, okay? But it's not as much about the product as it is about the timing of spraying, okay? They only work when you spray them once a week, okay? That's the hard part. In this picture down here, I tried a repellent study in this portion of this field and spraying every other week. No way. Got to eat to the ground, okay? Spraying every week is the only way to go. So, if you have to spray every week, is it really viable? No, okay? That's not our best option, all right? Now, of course, there's a lot of things going into this, right? It gets to be a pretty charged situation. A lot of things contributing to the problem. In my opinion, I think that hunters have to be part of the solution, okay? Hunters got to do their part. I know a few of the guys in this room hunt. I know a few of us had us a little running bet this year trying to see who could tag out first. Seth McAllister did win that bet, and he's in the back there. In my opinion, DNR increasing the limit or extending the season isn't going to do any good. Okay, why? Why is it not going to do any good? Because of this graph right here. Okay, 84% of licensed hunters in the state of Georgia kill 1 or less does in a hunting season. Okay, if they're not shooting them during the regular hunting season, what's extending it a month going to do? What's increasing the limit to 15 going to do? Okay, it's not going to do any good. All right, less than 0.5% take more than 7 does. Okay, I'm part of that. Dr. Snyder's part of that. Seth's part of that, right? Trey's part of that. We all try to do our part, okay? I do think that the increase in availability and funding for the Hunters for the Hungry program has potential to help if it's taken advantage of. Now, I did have a conversation with a colleague of mine a couple months ago, and she told me, she said, I don't think hunting's going to fix the problem. I kind of stopped, and I said, what do you mean hunting's not going to fix the problem? I said, I think that's the only way to fix the problem. She said, no, you don't get what I'm saying. She said, hunting's not going to fix the problem. Killing's going to fix the problem, right? Whenever we go out there and we spray stink bugs or plant bugs or whatever, we don't just go look for them, right? We kill them, okay? Spray something, kill them, all right? So this is a long road type issue. Overall take-home message, I promise you, we're doing everything we can, okay? A lot of that is producer-supported research, okay? So we're doing everything we can with the resources that you are allowing us to use to try to find solutions and learn the severity of the issue. We're learning that it's not easy. Of course, we got plans for more students to begin other projects and stuff like that. And of course, I intend to keep doing what I'm doing my part. If you farm in those 3 counties, I tried to help you out a little bit. Okay, Tift, Terrell, and Greene County. All right. Thank you guys for coming. I know that was a little different. If you want to hear the normal county meeting talk, I'll be in your county at some time. Okay. Any questions for me while we kind of switch up to Dr. Snyder's presentation?
All right, well, good morning, everyone. My name is John Snyder, and I'm a cotton physiologist here at the University of Georgia in Tifton. And I'm going to do something a little bit different today as well. I guess we just kind of decided we're going to change things up a little bit. Normally, I would be in here and I'll talk a little bit about, would be talking about lint yields and some of the physiological drivers of lint yield in response to any number of things, whether that's variety selection or crop management decisions or some sort of environmental stress. But what I want to do today is I'm going to change that up a little bit, and I'm going to focus on cottonseed. Cottonseed research has been a pretty significant portion of the work that my group does over the years. And so I'm kind of going to just start this off with, why is it that we, of course, why do we care about cottonseed? For one, of course, that's the foundational yield component in cotton, but also cottonseed makes up about 10 to 15% of the total value of the cotton crop. So, we all know that, of course, that's going to help pay the ginning costs and so forth, but what is it that cottonseed is used for? So if you think about the total supply of cottonseed, and I'm not going to give an economics talk. There'll be somebody to do that later today. But But ultimately, what is that seed used for? So some of that seed is going to be, it's going to be crushed, and of course that's going to get you your oil, and that oil will be used for food processing purposes, and then you know, some cottonseed meal, and then the majority of it, let's see here, for feed, you know, for feed and then for planting seed. So if you think about kind of the main uses of cottonseed, you're going to have the majority of it will be fed whole to cattle, but there's some portion of it, of course, that is grown on seed production farms for planting seed. And of course, those are not going to be here in Georgia. Those are going to be more out west. That's where most of the planting seed is produced. But I would say that a lot of, you know, we kind of lack a lot of basic management information and how that influences planting seed quality and that type of thing. The other thing is that whenever I say that it makes up about 10 to 15% of the value of the cotton crop, that kind of varies. It depends on the year, right? The price of cottonseed, and then of course the price of lint, which of course whenever lint prices are low and cottonseed prices are higher, it makes up a higher percentage of the total value. So the other reason that we care here is that seed composition does affect the value of that cottonseed. So oil is the more economically valuable portion of the cottonseed. And in addition to that, that oil content will can influence seedling vigor, and I'll talk a little bit about that here in just a minute. The other thing is that seed traits that, like seed size, for example, can affect the ginning process. One of the things that and again, this is not my area, it's something I've just recently become aware of, is that, you know, years ago, ginners kind of came up with this kind of a guideline that, hey, we don't really want seed, we don't really want varieties that have a seed index, you know, less than 10. And just for those of you who are, just for reference, the seed index is just the weight in grams of 100 fuzzy cottonseed. Okay, it could be fuzzy seed, could be delinted. In this case, it's these fuzzy cottonseed, and so nothing less than 10. And the reason for that is, you know, the smaller those seed are, the more challenging it is during the ginning process, and it actually, you know, it's a slower ginning rate and higher energy requirements to carry out that ginning process. And so I'm going to show you this just real quick. This is some data that we got from our on-farm variety trials, and I'll kind of walk you through what it all means here in just a minute. But I had a student, one of the things we don't look at a lot is, again, in our variety trials is seed characteristics. And so whenever our, you know, both in collaboration with camp here and our county agents, whenever we would get our seed cotton samples back at the microgen, we'd pull a subsample of that and we'd gin it, and then we'd get, instead of our lint turnout, right, we'd get our seed turnout. And then we could calculate our seed yields, we could calculate a lot of other things, but along with that, we'd weigh out these seed, and we'd get seed index at each environment. And so there's what, I think from those that we were able to get, 20-ish locations throughout the state. And so this is just on the x-axis here, you can see that is the average for every variety that's at that location. And then this is the actual value for a given variety. And so what all of this is just showing you, the first thing that you'll see here, I said that seed index, you know, they'd like to see it above a 10, right? And in reality, if you take even our largest seeded variety in the trial, which was this Dynagro 3799, basically it'll be somewhere from a 9.5 to about a 10.5 across all locations, and that's the only variety that kind of meets that criteria. So what does that mean? Over time, of course, selection for higher lint yields is producing smaller cottonseed. That's kind of the take-home message there, right? But you can see there's a lot of variation due to variety. You see a similar responsiveness for our smaller seeded variety here. So this is, I think the smallest one in the trial was, let's see, Delta Pine 2038. So there we have our largest seeded one, our smallest seeded one here, and so that goes from about a 6.5 to a 7.5. So all, you know, pretty big differences here. There's clearly a variety component. The seed index does respond to environment, to production environment. But why this matters, why I'll kind of want to point this out too, is I have gotten kind of comments over the years, well, if I'm picking a variety from the variety trials and I pick, well, a smaller seeded variety, or let's say I pick a larger seeded variety, there's some that have the perception that selecting that larger seeded variety is somehow going to cost them yield. I would argue that, those two varieties, both at opposite ends of the seed size spectrum there, right? Those for 3 years running were right at the top of our yield, in terms of our average yield for our variety trials. So again, both high yielding varieties. So that decision, of course, needs to be made based on actual yield data rather than assuming that if you select a smaller seeded thing, you're somehow going to get, a larger seeded thing, you're going to somehow get lower yields. Now, seed size and composition, the other reason that we care about, and this is where most of my research has been, the reason we care about seed size, the reason we care about seed composition is that both of those things can affect seedling vigor. And what I want to tell you, what I want to talk about here is whenever I first got here, I had come in after a year that was pretty challenging for stand establishment, and so I sort of inherited this data set, and then we had samples run for seed oil and protein and that kind of thing. But essentially, within the variety trial, you had some varieties where you had really, really low stand establishment, and then right next to it, you had varieties where there didn't appear to be any limitations to stand, okay? And so there was some concern that this might be a seed quality problem, that we may not be getting good quality seed from the companies and what have you, and in reality, all of those tested really high for seed germination. Warm germ, cool germ, these were high quality seed lots from a germination perspective, but why is it that we were seeing these differences in stand establishment? And to understand that, I think you have to kind of take a look at the process, the germination and emergence process. Of course, germination starts once that seed starts taking up water. It ends whenever that radicle comes out of the seed coat there. And then a lot of times people refer to this as germination, and that's fine, but this is what we call emergence, right? Getting those cotyledons above the soil surface there. But between A here and E, until we get to E there, where those cotyledons are fully expanded and they're photosynthesizing actively, where is the energy coming from? Where is the food coming from? Where's the fuel to drive the growth of that seedling? Until those cotyledons expand, where's the energy coming from? It's coming from the seed, right? It's whatever was in that seed when it was put in the ground. And so what we found was basically we had these differences, and especially it just really popped out in these more challenging production environments. But each one of those dots is averaged across, I think it was 5 different locations. But essentially, if we had higher calorie content, which is a function of both the seed size and the oil and protein percentage in that seed, it was pretty predictive of seedling fresh weight. So we were using that as our measure of vigor. We also had dry weight measurements, which showed really the same trends. Now, I want to kind of change this up. We did a lot of other work, and this was a much more data-dense presentation previously, and I went ahead and trimmed it. It's still pretty heavy on the data, but I wanted to just kind of focus this on one specific project. So within a variety, how much can we really affect seed characteristics, and how much can we affect, for example, the oil and protein content? And then let's take that a step further. How can these management practices influence our oil, protein, and seed yields? And so what I want to talk about next is this trial that we did. And of course, the trial itself was primarily focused on lint yield, all right? And I will briefly mention that at the very end. But what we did is we evaluated 2 different irrigation strategies. So we had our dry land and we had our irrigated. We did this trial down in Camilla at Stripling Irrigation Research Park. And so, having that facility there allows us to randomize our irrigation treatments. So we got 3 different pivots, and we can basically flip a coin and decide which half of that field gets irrigated and which doesn't. So we can replicate that 3 different times. And so we've got our irrigated and our dry land treatment. We had 3 different PGR treatments that we are calling an untreated, a moderate, and an aggressive. You can look at the details there. But it's really just, with untreated, that's pretty self-explanatory, but with our moderate treatment, we wouldn't have started until we got to first flower. So we'd put out our first application at first flower, and then we'd come back 2 weeks later and do a second application. And the only difference with the aggressive was we started our PICS applications sooner. So we would have had an additional application during squaring, really at the start of squaring. And so just to show you that what is untreated, moderate, and aggressive really does generate differences in growth, this is just showing, this is basically this line right here is just a yardstick. So we've got some cotton in here for all other management practices being the same. I believe this is for our standard recommended practices here. You know, we've got cotton that may be pretty close to 6 feet high. We've got some that's a little bit over a yard here, and others that is actually a little shorter than a yard. So we can generate pretty drastic differences in growth there. Again, not a big surprise, but again, just showing kind of the experimental details there. And then we had 3 different nitrogen rates. So those nitrogen rates would be, of course, we have an untreated there, and then we have the recommended rate. So that site in Camilla would be considered a deep sand, and our recommendation was to go with 120 pounds with the deep sand there. We had 180 pounds as well, and I've got these also in kilograms per hectare. I get comments about using metric units always after this meeting, so I apologize to those of you that there's going to be some metric units in here, but you'll still see the trends. And so just to kind of move forward with this, and this is what I wanted to do this morning, Kemp, but I do not have my license for J&P, and just split it down into one graph and focus, right? But no. What this is really just showing here is the effect of nitrogen on seed yields and seed characteristics. As our nitrogen application rate goes up, we basically see higher seed yields. But we also see higher seed protein, and we see a reduction in oil content. So, you know, a seed can only hold so much, right? So if the protein content goes up, then the oil content has to drop, okay? If we look here at our oil yields and our protein yields, they're really showing us exactly the same thing. So again, nitrogen rate, 0, 120 pounds per acre, and then 180 pounds per acre. And what you see here is basically any of them that got fertilizer, whether it was our recommended rate or the really high rate there, they're basically achieving the same yields because the protein yield and the oil yield are tracking the seed yield essentially, okay? If we get down to the irrigation stuff, I thought this was real interesting, and I want you to focus on 2023, and keep in mind the seed were collected, they were ginned, and then they were analyzed for oil and protein this year. So this is the complete 2-year data set here. But if you'll have a look here, in 2023, if you'll remember what happened during that year, we got a pretty severe drought, at least at this location, between peak bloom and cutout. So during that seed development period, and what we saw is reductions, of course, in seed yield. And the interesting thing is you see that, and you also see an increase in protein content of the seed, percent protein. Why would the protein content of the seed go up when our seed yield drops? Anybody want to kind of speculate on why that is? I may just jump to it just to save time, but I don't know. Anybody show of hands? Anybody want to guess? All right, so let's just think about this. Under drought stress, you've got the same amount of nitrogen that you've put out there, right, per unit land area. The crop has already reached canopy closure. It's all, you've basically already built that structure. But drought stress causes what? It causes those bolls to shed, right? So you'll lose fruit. And then now, and basically we lose it early during that fruit development when it really hasn't accumulated any protein, okay? And so then, once you lose that, you've got fewer fruiting sites to distribute the same amount of nitrogen, right? So there's more nitrogen per reproductive unit. Our protein content goes up. When protein content goes up, what happens to oil content? It drops, okay? So that's kind of what we see here. And the interesting thing is because the protein content of the seed went up, even though the seed yields dropped, we didn't see a significant difference in protein yield per unit land area. And then if you look at oil yields, they're even more drastically affected under drought. So interactions. So we did see some interactions. That's what we were really looking for is, are there interactions between one management practice and another management practice, either between irrigation and PGRs or between nitrogen and PGRs. And so we did see some interactions in 2022 for our nitrogen rate and our plant growth management. The short story here is if we don't have nitrogen, right, if we are limiting growth through some other thing like nitrogen, the same thing applies for water, right? If that's what's limiting growth, then applying PGRs has no real effect, right? In this case, as the nitrogen application rate goes up, we start to see a benefit to applying PGRs. So the higher seed yields here are those that got either an aggressive or a moderate PGR application. But it only matters if we've got sufficient nitrogen to drive that growth, right? The same trend is here for oil yield as well. And then I'm going to kind of move through this a little bit quickly. But I told you that the oil percent of that seed, or the oil content of that seed, is pretty important. And so what I want you to see here is under dryland conditions, if we increase our nitrogen rate, we see a reduction in the oil percentage and we see an increase in the protein percentage, okay? And we've kind of talked about that, but that's a response to nitrogen, okay? But as long as we've got water, that oil content is stable. That oil content is stable even at the higher nitrogen rates, okay? One last thing, the only thing we saw affect seed size, and we see this consistently, is PGR management. So as long as we're controlling vegetative growth in some way, we can take something that's got a seed index of about a 9.5 there and bring it up to about a 10.5, all right, by just controlling vegetative growth. And so I'm going to jump to kind of the main thing here, and that is, and this is where I want to mention some of the lint yield stuff as well, okay? So as long as we are using our recommended irrigation strategies, our recommended nitrogen rates for that site, and a moderate PGR strategy, that seemed to be kind of the combination of practices that maximized both our, and I'll just, because we've got all this lint yield data for this, which I'm not talking about today, it maximized our lint yields, but it also had a positive impact on our seed characteristics and our seed, oil, and protein yields. So basically the total value of that crop, both for the fiber and of course this co-product of the seed, are maximized using that combination of strategies. All right? So with that, I'll stop and open it up for any questions. I don't know how quickly. It says 20 minutes. So anyway, yeah, I got through it reasonably quick. All right.
Seed's going to be important this time because fiber ain't worth much.
It's still the majority, but but it is,
Just a reminder, we got pesticide credit forms up here and variety trial results if you're interested. Next breakout session starts at 9 o'clock and it's across these 3 rooms. All right. Thank y'all.